Hi, and welcome to Turing Talks. If you don't know who we are, we publish articles and videos on building and deploying LLM models to production. So, in today's video, we're going to look at how the bag of words algorithm works. Bag of words is one of the earliest algorithms that helped us get started in the world of natural language processing. So, these are the foundation of language models and showed us how we can convert text into numbers so that the computers can understand and make sense of a large corpus of text. So, modern AI tools like ChatGPT, they seem intelligent, but their roots really trace back to this simple method, which is bag of words. Bag of words was one of the first ways to turn text into numbers because, as you know, computers cannot read text and understand it. They can only understand numbers. So we needed a way to convert text into numbers so that the computers can make sense of the text. So bag of words is basically a representation in which you have a group of words and you assign numbers to it. It ignores word orders, grammar, structure. It does not have the context of a sentence. It only focuses on the presence of frequency of words. So basically, it just counts the number of words. For example, you can see here the cat sat on the mat. There are two occurrences of the word the. That's why we have the frequency as 2. We have one word cat, sat is 1, on is 1, and mat is 1. So you can see here different sentences can look the same if the words are identical. So bag of words does not capture the meaning. It only captures the frequency of the occurrences. Now let's quickly write some code and understand how this works. And then we will come back to see why bag of words is important. So I have a Google Colab notebook. I'll put a link for this in the description below. So what we're doing is we are using the sklearn library, which is a very popular library in Python for natural language processing. And we're using the count vectorizer class. So basically, this converts a collection of raw text documents into numerical representation. So let's import this. And here what I'm doing is I have taken an array of 3 phrases. The cat sat on the mat, the dog barked at the cat, and the mat was sat on by the cat. So what we're going to do is we are going to use the count vectorizer and we are initializing the class. And we are simply going to convert this text into a bag of words. I've used the fit transform function. So basically what fit transform does is it'll fit the vectorizer on the documents and transform them into document DOM matrix, which means each row becomes one document. So each row will be considered as one document and the frequency would be counted. And then we will get a vocabulary. A vocabulary is nothing but the number of all the words here. For example, the will be a word in the vocabulary. And then bag of words will tell you how many occurrences of this word occurs in this entire corpus. So let's quickly run this code. You can see the representation. So vocabulary is all the words that are present in these 3 phrases. And then each of this document is represented as a function of this vocabulary. So what it is saying is taking this vocabulary. So this is the 0th index, 1st index, and 2nd and 3rd and so on. That's the same represented here. And what this is saying is in this vocabulary, comparing it to this document, what are the words that are present? So the first is at. At is not present in the first phrase. Barked, no. By, no. That's why it's all 3 zeros. If you look at the 4th one, that's cat. Cat is present in this vocabulary. So that's why we have 1. The next word, dog, is not present. So similarly, if you take the second one, at is present in phrase 2. So that's why it's 1. So you can see that bag of words basically builds a vocabulary using all the words in a list of sentences or a large document corpus, and then assigns these frequencies to tell you how many occurrences of a word in this vocabulary is present in the document. So here we can look at the frequency 2, which means what's the second to last element? The is present 2 times in sentence 2. That's why you have 2 here. So I hope you get the idea. So bag of words basically builds a vocabulary using the number of sentences and then tells us the frequency of the words. This might not seem very useful, but we will see why it is. Now, bag of words was really a breakthrough because before bag of words, computers couldn't easily handle text. As you know, computers work with numbers. So we needed an initial way of representing words into numbers so that the computers can understand or try to make sense of it. So bag of words transformed words into numeric vectors, and it helped us to start using some statistics and clustering and machine learning on text. Before bag of words, all we were working with was numbers, and we were able to do machine learning computations on numbers, but bag of words helped us to represent words into numbers so that we can start using the same machine learning models on text. And some of the early applications of bag of words included spam filters and even search engines. Now, strengths, it's very simple and it's effective for turning text into numbers, and it works well for basic tasks. Whereas the core weakness of bag of words is that it does not have any context or meaning, and it also treats synonyms as different words. And it creates large sparse vectors, which means it creates a huge vector. It takes into consideration every single word, where there are much more sophisticated algorithms today that powers modern LLMs like GPT, which does not consider all the words, but they build more like semantic trees, which help them to identify synonyms, antonyms, and group words together. Now, what happened after bag of words? We got TF-IDF, which weighs rare but important words more. So it added some level of complexity and efficiency for the bag of words algorithm. And then came word embeddings. This was the second breakthrough. So now word embeddings were able to capture meaning and relationships between words. And one popular library was word2vec. I'll also make a video on word2vec sometime in the near future. But converting words into embeddings rather than simply bag of words was a huge breakthrough. And then came the transformers, which you all know. So it captures context and word meaning dynamically. Now, do we still need bag of words? Yes, it's still useful for small projects and quick text classification tasks. And it's very faster and lighter than deep neural network. You don't always need an LLM for every single task. There are much more efficient and smaller models that we can use for specific problems. And it's also a great teaching tool. It shows you the first step of converting text into numbers, because if you want to build LLMs from scratch, you have to understand how this all started. So the core idea of bag of words lives on modern models, and so basically we convert text into numbers and then vectors. That's the whole basis of large language models. So bag of words looks primitive, but it was definitely a turning point in LLP, and it showed us how to represent language as data or numbers. And it is one of the spark that started today's transformers and large language models that we use. And yes, bigger revolutions often start with simple ideas. So I hope you enjoyed this video. If you have not signed up to Turing Talks, please go and subscribe, and we will send you a couple of emails every week with our new tutorials and videos, and you can stay updated with our latest content. Hope you found this video useful. I'll see you soon with another one. Cheers.